All right, if you thought the earlier Coulomb's law problem was just a little too easy, here's the other one. So this is the more advanced version. Takes a little more effort, a little more forethought, a few more steps too. So you've got this scenario here. You've got 3 charged particles, and you need to figure out what is the force acting on the 4 microcoulomb charged particle. All right? So that's your mission. I will come back with the answer in a moment. So pause the video and do some work. All right, so there's your answer. There's the magnitude of the force is 20.76 newtons, and the direction of the force is 74.29 degrees south of west. All right. So let's see how we arrived at this. So if you got it, awesome. If not, let's talk about it. So let's do the basics. First, most importantly, you need to realize you have multiple interactions here. In fact, you have so many interactions, there's actually 3 different times you have to do Coulomb's law to really get this. So let me show that to you. So these are the 3 force interactions. So 3 times we do Coulomb's law. The first one is in between the 3 and the 4. So here's one interaction, this one with that one, okay? We know the radius is 8, we know the numbers, we can crunch it, do the math, find the magnitude of the force. Then, you'll notice I did one in the x-plane here, all right? Because this, if I wanted to, I could do the distance here and figure out this radius, which actually is also a 3, 4, 5 triangle, fundamentally. So this is 10 meters, but you don't really want to use that because you are going to add the x's to the y's. So just like we did regular forces, we want to keep our x's and y's separate until the very end and then put them together. So that's why I actually did the math in just the x-plane. So if you look in the x-plane, then the distance is 8 meters in the x-plane. If you look in the y-plane over here, then you see I did same forces, but the distance, or the radius I should say, is different because I'm going to use the 6 centimeters because that's the vertical displacement here. So then I have the x and y components of this interaction here, and I also have the force interaction between these two. Now, if you really wanted to, I just did it like this, but if you really wanted to, you could say, well, I got this force, and it's going to be this angle, so you could, once you calculate the force using only one radius, so just do Coulomb's law once, you could then say, well, what's the components of that triangle? Because you'd say, oh, well, this guy is pushing this guy that way, so you've got this force here. What's that component? What's that component? You could do the math then and add them up. So you could just do 2 separate Coulomb's law with the 2 different vertical and horizontal radiuses, or you could do 1 Coulomb's law and then break it up using trig. Totally up to you. 2 ways, both work. But once you have all these forces, then we got to put all back together. So it's really important to draw a really good force diagram for the situation, and then we're going to use Pythagorean theorem and some basic trig to solve this out. So here you can see I got my basic force diagram. So the 3 Coulomb is going to be pulling on the 4 Coulomb because they're opposite charges, negative and positive, so we're just going to be pulling it. Then we have positive and positive, so it's going to be pushing it. And as I drew earlier, it's going to be pushing it to the right, it's going to be pushing it down. So we have the x is to the right, and the y is down. Well, when we add these all together, we really get this as our force diagram. The net force in the x-plane is basically a negative 5.625, and the net force in the y-plane is basically a negative 20. So this right here, this is my net force that I'll need to calculate. So to do that, I have to use the Pythagorean theorem because I have to put these two together because I've got my 20 and my 5, make a triangle. What's the hypotenuse? Use Pythagorean theorem, you get your 20.76. Then I want to figure out, well, what's this angle here? What's that angle theta? So to get that, I basically just use tangent because I've got x and y components. So you get 74.29 is your angle with that, and then it's south of west because if you start west, you're heading to the south. So it is 74.29 degrees south of west. And so this is your total answer right here. It would be like one long statement. All right. Hopefully that worked out. Hopefully you followed it. Hopefully you and Coulomb are hanging tight. Bye-bye.